According to the United Nations Framework Convention on Climate change means a change of climate which is attributed directly or indirectly to human activity that alters the composition of the global atmosphere and which is in addition to natural climate variability observed over comparable time periods. One of the main drivers of anthropogenic climate change is global warming, which is mainly attributed to the combustion of fossil fuels, primarily for energy production, for example coal-fired power stations. This releases greenhouse gases such as water vapor, ozone, methane, nitrous oxides, and carbon dioxide into the atmosphere, which traps solar energy and leads to increased global temperatures. There is general scientific consensus that it is this greenhouse effect that is contributing to climate change and global warming. Accidental greenhouse gas releases also contribute to global warming, such as the recent methane leak from an underground methane storage facility in Porter Ranch, California, prompting a state of emergency to be declared. The Stern Review of 2006 estimates that the current level of atmospheric carbon dioxide is 430 parts per million and rising by more than 200 parts per million annually. The review also estimates that if no action is taken, the overall cost of climate change will be equivalent to losing at least 5% of global gross domestic product each year now and forever. However, climate change can have both positive and negative economic effects. Negative economic impacts of climate change. Extreme weather events. The IPCC states that a change in climate leads to changes in the frequency, intensity, duration and timing of extreme weather and climate events. Extreme climate events can include droughts and heat waves, which severely impact crop production, which has a negative effect on a country's gross domestic product, along with increasing the likelihood of wildfires causing damage to homes and infrastructure. For example, the World Bank estimates that the wildfires and subsequent waves seen in Indonesia in last year have cost the country 221 trillion Indonesian rupiah, or 1.9% of its GDP. The damage caused by storms, tornadoes and hurricanes also caused massive recovery costs. Hurricane Katrina, which struck the United States in 2005, is estimated to have caused $47.424 billion worth of damage. Ocean warming and sea level rise. As the global atmosphere rises in temperature, so does that of oceans. This causes not only the thermal expansion of oceans, but also the melting of polar ice sheets, resulting in a rise of sea levels. It is estimated that the upper 75 meters of the world's oceans have warmed by 0.11 degrees Celsius per decade between 1971 and 2010, and as a result, global mean sea levels rose by 0.19 meters between 1901 and 2010. As sea levels rise, so too does the likelihood of flooding, especially in lowland coastal areas. This causes huge costs for the construction and maintenance of coastal flood defences. For example, just the management and maintenance of the Netherlands' primary flood defences is estimated to cost €350 million per year. Ocean acidification and effects on marine ecosystems and fisheries. The IPCC predicts with high confidence that ocean acidification, caused by the uptake of carbon dioxide from the atmosphere, which is converted to carbonic acid in oceans, will strongly affect marine ecosystems and fisheries. Increased ocean acidification hinders growth of calcium carbonate shells and skeletons of many marine plants and animals. In 2007, the $3.8 billion U.S. annual domestic commercial fishery harvest contributed $34 billion to the U.S. gross national product. Substantial revenue declines, job losses, and indirect economic costs may occur if ocean acidification continues to damage marine habitats and alter marine resource availability. Positive economic impacts of climate change. Increased crop production in high-latitude regions. As global warming increases temperatures in high-latitude regions, food production in these areas will increase as species of crops which would normally be unable to grow in the colder northern climates will be able to be harvested. Lobel and Gourdier predict that Carbon dioxide and global warming trends will likely increase global crop yields by roughly 1.8% per decade. This will positively impact the economies of such areas. Decreased cold-related mortality rates. It is very likely that the number of cold days and nights has decreased and the number of warm days and nights has increased on the global scale, resulting in decreased cold-related mortality in some regions. Siskar et al. Estimate that the decrease in cold-related mortality rates ranges from 60,000 to 250,000 deaths per year as a result of warming global climates. This would mean a decrease in the costs of caring for those afflicted with cold-related health issues and mortality. Increase in the sustainable energy production industry. In efforts to combat anthropogenic climate change, there has been a vast increase in the development of renewable and sustainable energy production techniques. Warwick of the Washington Post reported that wind and solar power appear set for a record-breaking year in 2016 as a clean energy construction boom gains momentum in spite of a global glut of cheap fossil fuels. Orders for 2016 solar and wind installations are up sharply, from the United States to China to the developing economies of Africa and Latin America, all in defiance of stubbornly low prices for coal and natural gas, the industry's chief competitors. Energy analysts say the boom is being spurred in part by improved technology. In November, Goldman Sachs announced it was quadrupling its investment in renewables to $150 billion. At the same time, the financing of renewable energy products has become a mainstream business for Wall Street. This increase in the investment, development, and construction of renewable energy production not only creates energy security for individual countries, but also positively impacts their economies by creating and expanding specialized jobs and workforces, along with creating local renewable energy industries. Case study: El Hierro, Canary Islands, Spain. In order to mitigate and slow the effects of anthropogenic climate change, some areas are taking great steps to reduce their use of fossil fuels for energy production and are attempting to move towards 100% renewable energy production. One such place is the island of El Hierro. Laura Pitt of the BBC reported in 2015 that for more than 30 years El Hierro has been taking steps to become energy self-sufficient. At the end of June 2015, its new hydro wind facility, Garona del Viento, came fully on stream, and in July and August it provided roughly half of the island's energy needs. This means the island's 10,000 inhabitants are less reliant on supplies of diesel arriving over unpredictable seas from Tenerife, 200 kilometers away. In July, Garona del Viento saved 300 tons of fossil fuels, but that is predicted to rise to 500 tons per month before long, the equivalent of saving 40,000 barrels of oil and 19,000 tons of emitted carbon dioxide per year. Garona del Viento's hybrid wind and hydro system consists of 5 wind turbines and 2 water reservoirs, one at 700 meters above sea level and the other down at the coast. They are connected by 2 3-kilometer long pipes, with the water draining from the upper to the lower reservoirs passing through water turbines to generate electricity. Fresh water is used rather than seawater to prevent contamination of aquifers should any leaks occur, although an existing desalination plant is being used to make seawater usable for the reservoirs. The key disadvantage of wind power, the unreliability of the supply, is made up for by the water in the upper reservoir, which can be released within milliseconds whenever the wind starts to blow less strongly. The system is continually switching between releasing water from the upper reservoir and pumping water back up, depending on the strength of the wind and the demand for electricity. However, this disadvantage of wind power is lessened by the fact that El Hierro has an abundance of wind resources, with a yearly average of wind velocities and densities well in excess of 7 meters per second and 300 watts per meter squared, which are the minimum conditions required to implement a profitable wind project. The hybrid use of wind and hydro energy means that the hydro pumping system will work with surplus energy generated by the wind farm in times of low electrical demand or high wind production. Water will be pumped to the upper reservoir until it reaches maximum capacity. Surplus energy beyond this point will be used for the desalination plant. The current council president, Belen Allende, calculates that over 20 years, by not burning 6,000 tons of diesel per year, El Hierro will save the central government about 80 million euros. There are some, however, who argue that the cost of building Corona del Viento, 82 million euros already, means that in reality the electricity is not cheap at all, but actually very expensive. Hallam et al. Argues that the project is a milestone in the adoption of renewable energy technologies and is being closely watched by members of the power community for potential applications elsewhere in the world.